Hello viewers, welcome to CEC lectures. Myself Dr. Preeti Jagwani. I am from Department of Computer Science, Arvind College, University of Delhi. In this present series of database management systems which we are going through, in the last lecture, if you can recall, we have started with the topic of transaction management, and today in today's lecture also we will be carrying forward with that transaction management. What we are going to cover today is basically we have seen the asset properties last time in a very brief manner, and now we are going to get into the details of those asset properties, all four, and then we will be discussing about the storage structure of the storage structure details which are relevant to the transaction management. With this agenda, let us begin with our today's lecture. So in order to give you a quick recall or a quick recap, let me define the transaction once again. That is collection of operation, we can say, that is going to form a single logical unit of work, and it is going to possibly update various data items in a database. So for example, the simplest example of a transaction is transfer of money from one account to another. That is something a step, a procedure I can say, which is consisting of two updates, one to each account. From one account the money is being transferred into the another account, so one is being credited, another one is being debited. So two data items are being we can say updated and accessed also. This is what I was saying, that access and possibly update its various data items. Now the thing is, how this transaction is going to be written or initiated. So basically a user program has the responsibility of initiating a transaction which is written in a high level language. Generally the transaction is written in a a standard query language, which we have also seen in our earlier lectures, but it is not necessary that transaction is always written in SQL thing. It could be any programming language, any high level data, any high level data programming language, which is, we can say, C++, or it could be Java or any other for that matter. And then how are we going to recognize the transaction? So that is going to be in whatever steps are there in between the two terms, which is the begin transaction and the end transaction. So we can say a transaction is actually something which is delimited by the statements of the form begin transaction and end transaction. So this was, we can say, a general idea or a quick recap about the transaction thing. Now we will go through a particular transaction of this kind of transfer which I was talking about, and then we will be looking into all the asset properties, that is atomicity, consistency, isolation and durability in detail. So for example, let us say we have a transaction and we are naming that transaction as T of I, and that transaction is something which is transferring sum of $50 from account A to account B. This is a very we can say typical or standard example of transaction. So this transaction can be defined as, first of all, the account A, or the balance of account A is going to be read. Then it is going to be kind of, we can say, updated, where A is A minus 50. That means we have taken out $50 from account A, and then we need to write A. That means the lesser balance is being updated there. Then B, account B, or the sum of the account B is being read as read B, and then $50 has been kind of, we can say, added to the sum, which is going to make an update an excess of B, and then updating it by $50 plus, which is B is equals to B plus 50, and then this final or updated amount of B is going to be kind of written onto the disk. So this is basically a structure of a typical transaction, as we can say. Now when we talk about all the asset properties, which are atomicity, consistency, isolation and durability, now let us see how these properties are going to be maintained within taking the example of this particular transaction of transfer of $50 from account A to account B. So, here for the sake of simplicity or for the sake of understanding, we are not going to take the properties in the order of A, C, I and D, rather than we will begin with the consistency first. So, consistency, when we talk about consistency, actually means here in this with reference to this particular transaction, the consistency means that the sum of A and B should be maintained by the execution of the transaction. That means whatever we can say database must be in the consistent state before beginning of the transaction, and it is a mandatory requirement that after execution or after ending of the transaction, that should also be in the we can say the sum of A and should be preserved, and hence we can say the database is in a consistent state. Now, why do we need consistency? So, just imagine that if there is no consistency requirement, that means essentially in this example we are saying that money can be created or destroyed by the transaction or by the system, which is invariably not possible. Money should not be created or destroyed by the transaction itself. So, here or all in other we can say other type of transactions, the consistency requirement has to be maintained. And yes, consistency or the consistency of database is something which is we can say easily verifiable. We can verify that before the transaction your database was consistent, and after the transaction also your database is consistent. And here in this for this example, the meaning of consistency says that the sum of A and B should be unchanged by the execution of the transaction. Then coming to the next thing, which is atomicity, which is the second property in the order in which we are considering. Atomicity says, let us say just before the execution of this particular transaction Ti, the values of accounts A and B are $1000 and $2000 respectively. That is we can say is the sum or whatever amount is there in the accounts. So, for $1000 are contained in account A, while B is containing $2000. So, during the execution of this transaction, let us say a failure occurs. So, that failures, because of that failure, what is happening here, your TI is not completing its execution successfully. That means somewhere between we can say it is kind of we can say it stopped or about it. Now, for example, suppose that this failure is going to happen after the write A operation, but before the write B operation. So, let us see let us take a look at the transaction once again. So, after the write A operation, that means the considering the balance of initial balance of account A as 1000. Now, whatever write A is going to write there is 950, and after this write A, your system failures or your transaction failure is going to occur. So, A has been deducted by $50. Now, we need to see that what is happening here. The value of accounts A and B reflected in the database are 950 and 2000 respectively, because 2000 is what the initial amount stored in B is, and it has not been updated because of the transaction failure, while write A has occurred and the money from the account A has been deducted. So, what is happening? The earlier sum of A and B was $3000. Now, the sum of A and B is $2950. So, that means essentially what we are saying is the system has destroyed $50 as a result of this failure. So, this is we kind of say is an inconsistent states, and because of this failure, the state of the system no longer reflects a real state of the database, or we can say it is reflecting an inconsistent states. Yes, we can say that immediate states may be inconsistent, but it should not, those states should not be visible. So, what I am trying to say here is, for example, money has been deducted from account A and has not been credited into account B. Now, at this particular state, so 950 and 1000 is going to give us 2950, that is an inconsistent state. But this is a state which is, we can say, an intermediate one, and this should not be, you know, kind of visible to the user. The visibility to the user should be allowed only after, you know, we can say coming to a consistent state, or coming to you know, after complete execution of the transaction. So, we can say if the transaction never started or was guaranteed to complete, such an inconsistent state would not be visible except during the execution of the transaction. So, while execution of the transaction is going on, system may have an inconsistent state. But if the transaction was never started, or it is guaranteed to complete, we should not get, or a user should not have this inconsistent state visible. So, this is what we can say is the reason for atomicity requirement. When we say atomicity, or a transaction is considered as an atomic unit, that means it is considered as one particular unit as a whole. So, that means all actions of the transactions are reflected in the database, or none of them is being reflected in the database. So, atomicity ensures that it should not happen that write A has been, you know, completed, that means $950 has been, you know, written and updated on the balance of account A, while, you know, the other half of the transaction has, you know, never executed because of some, you know, failures or something of that sort. So, in this state, when we are not able to preserve the atomicity property, that essentially means that database is going to be, you know, going to enter in an inconsistent state. So, inconsistent state. So, the reason for the atomicity requirement is something that an inconsistent state can happen during the execution of the transaction, but if the transaction was never started, that means before the transaction the database is in a consistent state, and after the transaction, that means if the transaction is guaranteed to complete, this should not have an, you know, inconsistent state after completion of the we can say transaction. So, if the atomicity property is present, then it is going to ensure that all the actions of the transactions are of a particular transaction are reflected in the database, or none of them is, you know, going to be reflected. Now, this is what about, you know, what actually atomicity is and why do we need to ensure atomicity. That is fine, but how are we going to, you know, take care of this atomicity, or how this atomicity can be ensured? If we want to go into, you know, deeper inside of that, we will encounter a particular term which is known as logs, or more specifically we can also say them as log files. So, basically database system is a database system, what it is going to do is it is going to keep track of the old values of any data on which a transaction performs a write. So, for example, in the in this the present example which we are looking into, which is of account transfer of $50 from one to another account, before writing any, you know, writing statement, or before execution of any writing statement, the old values are going to be, you know, kind of tracked, or we can say the old values are going to be preserved. So, even if a statement which is write A, it has taken place or has executed onto the database, the old value of account A is somewhere, you know, we can say stored. And if your system is going to realize, or if your system is going if your system is coming to know that rest half of the transaction is not never being executed, that write A will also be kind of we can say abundant, and the original balance of the account A is restored. So that we can say is if a transaction does not complete its execution, the database system restores the old value from log, and here's what is we can say is the significance of the log files. So the database system restores the old value from the log to make it appear as though the transaction was never executed. That means the transaction is we can say taken as an atomic unit, either it will be completed fully or none of these steps will be executed. So now with the help of logs, yes, here we can achieve the atomicity. Now whose responsibility is to achieve the atomicity? Is it the user or is it the application designer who is going to write such programs which may result in the atomicity property of the transaction, or is it the database system? So atomicity is a property which is not the responsibility of the user, but ensuring this atomicity is the responsibility of the database system, or we can say specifically it is handled by a component of the database system which is called which is more specific which is more commonly known as recovery system. So a component of the database system named as recovery system is going to ensure atomicity. It is not the responsibility of the user to ensure the atomicity. Now after this atomicity and consistency, let us going to take the last one, not the last one as in like acid, last one in the acid properties, which is starting from the letter D, that is durability. Now when we say durability, so durability could be of a product. Yes, that is what the term durable means, but here when we talk about in database systems, we can say once a transaction completes successfully, all the updates that it carried out on the database are going to persist even if there is a system failure after the transaction completes the execution. So now in the previous discussion, or in the discussion we have which we have just finished, we have seen that how this we can say writing of the or preserving of the transaction is going to take place in case transaction is not successfully completed. So that means if the transaction is not successfully completed and there is a crash, or we can say kind of a system failure, the whole transaction is going to be we can say revoked with the help of log files, because log files are having the previous data. Now coming to this durability thing, it says once the transaction is completed successfully, all the updates which are carried out on the database are going to persist, are going to stay there even if your system is failing after the transaction has completely executed. So the durability talks about the persistence of the changes when your system failure is happening or system failure is occurring after the complete execution of the transaction. So this says that after complete execution, or we can say after successful execution and notifying the user, that means the user has notified that so and so amount has been deducted from A, and the other user has also notified that so and so amount has been kind of we can say credited into the B. So after successful completion and notifying the user, it must be the case that no system failure can result in the loss of data corresponding to this particular transaction, or we can say corresponding to this transfer of fund. So once you have communicated to the user, even if a system failure, it should not result in the loss of a data corresponding to this particular we can say transaction. Now, atomicity, we have seen that how it is going to, how your system is going to ensure atomicity. That is with the help of we can say log file, or log file is a technique which is going to help us in ensuring atomicity. So, how are we going to ensure durability? That is with the help of one of the two steps, that is the first one says the updates carried out by the transaction have been returned to the disk before the transaction completes. That means we are going to signal the completion of transaction only after these updates which are carried out by the transaction have been returned to the disk. That is kind of one condition, and the second condition for ensuring the durability of the transaction, and one condition, one of these conditions can should be opted for. The second condition says, or the second statement says, that information about the updates carried out by the transaction and returned to the disk is sufficient to enable the database to reconstruct the updates when the system is restarted after the failure. So, either we have completed the writing of the whole transaction onto the disk, or we have sufficient information which is written to the disk in order to regenerate the transaction, or in order to reconstruct the updates when the system is going to restart after the system failure. So, both of these two we can say statements are indicating that either we should have a complete write, freeze it, or we have sufficient information to ensure that to ensure that update even if your system is failing after that transaction. So, we have seen atomicity, we have also seen consistency, and we have seen durability also. And now within the ACID properties, what are we left with is isolation. So, isolation, as you can understand, that in a particular system there can be many many transactions which are going on in parallel. So, if several transactions are executed concurrently, their operations may interleave in some undesirable way, which is going to result in the loss of consistency. So, for example, let us take one scenario within this example only which we are considering, that is of transfer of $50 from account A to account B. So, we can say the database, we have talked about intermediate inconsistency or a temporary inconsistent state when the transaction has already transferred from funds from A. Those funds have been kind of we can say deducted, but that those funds are not credited or yet to be returned to the B. So, deducted from A, the total is returned to the A, and the increased total is not yet returned to the B, it is yet to be done. So, now this is 950 and 2000. So, 950 for your account A and 2000 for account B. So, that is a temporarily inconsistent state, and that is we have talked about this particular scenario earlier. Now, what happens that if a second concurrently running transaction is going to read A and B at this intermediate point of time, and it is going to compute the sum of A and B, that transaction is going to observe an inconsistent value, because that inconsistent value is there of $29.50. Further, if this second transaction is not only going to read this value, but also going to perform some update on A and B based on that inconsistent value which that transaction has got, the database may be left in an inconsistent state even after both the transactions which are concurrently executing are going to be completed. So, what I am trying to say here is isolation is actually important if we talk about the scenario of implementation of these ACID properties, and that we have seen that if there are two transactions which are going on parallelly, then in that situation, or they are going on concurrently, then if the isolation is not maintained, then one particular transaction will take the values from another transaction when that transaction is an kind of temporarily inconsistent state. So, that is going to result into we can say inconsistent state of the whole database even after both the transactions have been completed. So, in this lecture we can say what we have seen is we have taken one example of transferring $50 from one particular account to another, and we have seen how these all the asset properties which are atomicity, consistency, isolation and durability are going to be implemented, and what actually they mean in terms of transaction. So, here is a list of references which is being used for the preparation of lecture. Hope you have enjoyed. I will see you in the next one. Till then, goodbye, take care.